now that we've taken a look at the identity matrix and an inverse matrix, we can now use these concepts to actually solve a matrix equation. So if we look here at this generic formula, AX equals B, we have a matrix equation where all of the matrices are 2 by 2 matrices, and X is the missing matrix. So we're going to say X is our variable matrix. So we know that we're going to be looking for the matrix X. And so in doing general algebra, this would work very similar to AX equals B. But the problem here is we would normally divide both sides by A to get rid of the A and have X by itself. Unfortunately, in matrix algebra, there is no division. You can't divide by a matrix. So we have to revert to the multiplicative inverse. And so if you remember, the multiplicative inverse would have us multiplying both sides times 1 over A, which in effect does the same thing as division. However, since we're using matrices and not real numbers, it works out a little differently. So you can see this matrix equation here to the left is very important as to understand this. Now, since we've already done this process, if we get an equation AX equals to B, we do not need to work every single one of these steps. We know AX equals B is going to equal to X equals the inverse of A times B. And so since that's the case, we can immediately go straight into that part of the equation and then use our calculators to make the necessary calculations. So let's look at sample problem number 2, how we're going to do that. We have part A and part B, and so I'm just going to help you set up part A. So here we know we have a matrix A and a matrix B, and we want to solve the matrix equation. And so we know from that previous algebra statement that X equals the inverse of A times B. Now, it's very important that you understand that it should not be set up like this. The inverse of A has to become before the matrix B, otherwise you're going to get an incorrect answer. So just be aware that you're doing that in the appropriate order. So if I set this up, if I say X equals the inverse of A, I'm going to take that inverse, I'm going to take that A and raise it to the -1 power to represent the inverse, and then I'm going to multiply that by the matrix B. So X equals to the following matrix. Now, if you wanted to check this, you could always come back and plug this in and say matrix A times matrix X, punch that into your calculator, and the resulting matrix should be matrix B. So go ahead and take a minute and do part B for sample problem 2, and then come back and check your answer. Okay, so matrix X is -29, -48, -21, and -34. So hopefully you didn't have any problems with that. So in the next couple of videos, in the later part of the notes, we're going to use our understanding of matrix equations and how to solve them.